247 hours in the Baltic Sea, the British Navy was suddenly placed on high alert after intense electronic interference began disrupting the area. Unknown contacts were detected tracking the formation from both above the surface and deep below, creating an atmosphere of extreme uncertainty. What unfolded quickly exceeded earlier intelligence estimates. A Russian destroyer was actively disrupting NATO communications at sea, while beneath the waves, a Kilo-class submarine was quietly controlling a key maritime corridor with long-range strike capability. It appeared as if Moscow was fully confident in its control of the situation. Within minutes, the balance of the operation shifted dramatically. Following the detention of 23 Russian ghost vessels carrying around 1.44 million barrels of oil, Moscow responded by increasing pressure on British naval forces operating nearby. On the surface, it was a familiar strategy, applying controlled military pressure without direct engagement, aiming to force a withdrawal through intimidation and uncertainty. Kilo-class submarines moved silently through contested waters. Their potential to deploy Caliber cruise missiles forced NATO planners to assume worst-case scenarios at all times. The formation became stretched and cautious, with anti-submarine assets pushed outward and every decision shaped by the possibility of a hidden threat, monitoring every move below. The British destroyer entered a full state of heightened readiness. Its radar and sensor systems scanned continuously across long distances, with defensive systems fully active. Yet the first decisive move did not come from above or below the waves, but through electronic warfare. From roughly 18 nautical miles away, the Russian destroyer Admiral Grigorovich activated its TK-25 electronic warfare suite, directing a powerful jamming signal into the X-band frequency range. In under 5 seconds, the main combat display was overwhelmed by heavy interference. The radar was not physically damaged, but it became unreliable for identifying or classifying targets, an even more critical limitation in a live environment. At the same time, the Kilo-class submarine remained still at about 42 meters depth, positioned beneath a strong thermocline layer that helped conceal its presence. It was only a few nautical miles from the target area. On the British ship, defensive systems such as Sea Viper were ready, but without a clear track, they could not engage. Efforts to restore full situational awareness began immediately, but the window for response was narrowing quickly. Every passing second increased the risk of losing control over the tactical picture. Above the scene, a USP-8 Poseidon aircraft continued deploying sonar buoys, but coordination delays and distance limited its ability to provide an immediate solution. This was not a confrontation defined purely by weapons. It was a struggle of timing, pressure, and decision-making under uncertainty, where the first miscalculation could determine the outcome long before any physical engagement occurred. As tensions escalated further, the USS Carney moved into formation, activating its Aegis combat system. With critical sea routes at stake, NATO brought in the destroyer to strengthen the group's defensive network. Unlike standalone systems, Aegis merges data from multiple sensors into a single integrated combat picture. High above, the E-2D Hawkeye aircraft acted as an airborne coordination node, gathering and distributing real-time information across the entire fleet. From the very beginning of the escalation, NATO relied on this airborne command layer, ensuring that data flowed instantly between US and British naval units without delay, creating a unified and continuously updated operational picture. 2 Russian reconnaissance UAVs continued flying at high altitude, maintaining a calm confidence that they remained beyond any threat range. Alongside the hidden movement beneath the ocean, Moscow also deployed airborne surveillance drones to observe NATO's response from a safe distance outside the engagement envelope. Inside the operations center of a Type 45 destroyer, the atmosphere tightened. The operations officer paused for a moment, fully aware that once Russia raised the intensity of the situation, the Type 45 would be placed at the very edge of the confrontation. The target was confirmed, and the decision to engage followed within seconds. 2 Aster-30 missiles launched almost instantly, accelerating into the sky at extreme speed, far beyond the limits of human reaction. Within less than a minute, both radar contacts vanished from the display. Tactically, the interception appeared clean and effective. However, on the Russian side, it marked something very different. Beneath the surface, the Russian submarine shifted deeper and shut down all non-essential transmissions. With aerial surveillance removed, the operational focus transitioned entirely underwater. The situation had not ended. It had simply moved into a more complex and concealed phase. NATO's confidence quickly faded as anti-submarine teams lost contact with the Kilo-class vessel. It was not that the submarine had disappeared, but rather that the ocean environment itself had become saturated with interference and distortion. Russia demonstrated an intimate understanding of these waters, timing its actions with environmental conditions, wind, currents, and background noise, so that natural turbulence masked subtle acoustic differences. In that moment, the submarine deployed a series of acoustic decoys designed to replicate the exact speed, movement, and hydrodynamic profile of a real vessel. On the screen of the P-8 Poseidon, multiple sonar returns appeared credible and equally threatening, making it impossible to confidently distinguish the real target from the false ones. As the data integrity degraded, the aircraft was forced to step back from direct tracking and shift toward passive data collection, leaving other assets to maintain coverage. Inside NATO command centers, tension escalated as radar and sonar feeds overlapped into conflicting patterns of false and partial signals. Operators faced an environment where threats seemed to exist in every direction at once. At this stage, the engagement was no longer a straightforward strike attempt. It had become a layered deception strategy. Russia introduced a wave of decoy missiles, some carrying inert payloads, designed to replicate the radar signature of a large-scale coordinated attack. NATO's defensive systems reacted automatically. British Aster missiles and American SM-2 interceptors launched in rapid succession, engaging targets that existed only as radar reflections. Each interception consumed significant resources, while the actual threat remained ambiguous. From Moscow's perspective, the objective was not simply to damage ships, but to provoke predictable defensive reactions, draining resources, fragmenting attention, and increasing operational stress across the fleet. In NATO operations rooms, the silence grew heavier as the scale of the deception became clearer. The conflict had evolved into a contest of perception and response rather than direct firepower. As submarine-launched acoustic decoys further saturated sonar networks, the USS Carney increased the output of its Aegis radar system to regain clarity. However, this also had an unintended effect, making the ship more detectable in the electronic battlespace. A Russian destroyer responded immediately with high-intensity jamming, disrupting radar functionality across the formation. Screens flickered, degraded, and in some cases went completely dark, erasing parts of the shared tactical picture in real time. With surface radar heavily disrupted, Russian forces believed they had significantly reduced NATO's visibility. However, they underestimated the redundancy of Western surveillance systems. Instead of relying solely on radar, U.S. forces transitioned to space-based observation. Data was handed over to the KH-11 reconnaissance satellite, whose high-resolution optical system continued tracking movements through the electronic interference layer from orbit, maintaining situational awareness even when traditional sensors were degraded. It didn't rely on radar to locate its targets. Instead, it monitored the ocean's surface with the precision of a long-range optical system, making what was once hidden suddenly visible again. In that sense, the KH-11 functioned like a hybrid of advanced telescope-grade optics and ultra-sensitive imaging technology, operating from orbit with global reach. What made it even more decisive was the way its data was transmitted. Information flowed through laser-based and ultra-high-frequency communication links, comparable to a hardened optical network rather than conventional radio. Unlike standard wireless signals that can be disrupted or degraded, this type of connection is far more resistant to interference, allowing intelligence to move rapidly and securely between platforms. Russian assessments initially assumed that satellite-derived targeting data would take a significant amount of time, around half an hour, to reach frontline units. Based on that expectation, they believed Kilo-class submarines could remain concealed beneath thermal layers, protected by the ocean's natural structure and acoustic distortion. However, that assumption proved inaccurate. Through integrated battlefield networking systems such as Link 16, precise coordinates were distributed to combat aircraft in roughly 90 seconds. The speed of this data transfer resembled high-frequency trading systems in financial markets, where decisions are executed in near real time, while others are still processing information. While one side was still compiling reports, the other had already acted on live intelligence and completed the engagement cycle. As traditional anti-submarine methods became less effective due to thermal layering and heavy acoustic noise, NATO shifted toward more unconventional measures. These were not standard procedures, but extreme contingency tactics designed for environments where normal detection systems were heavily degraded. F/A 18E/F Super Hornet squadrons were instructed to fly low over the sea at high speed, generating intense pressure disturbances across the water's surface. The resulting shockwaves propagated downward, disrupting the acoustic environment beneath the thermocline and turning the previously stable water column into a highly unstable sound field. For the submerged Kilo-class submarine, the effect was severe. Passive sonar performance degraded sharply, situational awareness collapsed, and the crew was forced into a reactive posture as environmental noise overwhelmed internal sensors. Unable to maintain a stable tactical picture and under mounting pressure, the submarine was ultimately forced into an emergency ascent, the exact outcome NATO had been anticipating. The moment the periscope broke the surface, an MH-60R helicopter operating at the perimeter descended immediately. Its dipping sonar activated and quickly narrowed in on the contact from above, restoring precise tracking in real time. From orbit, the KH-11 provided continuous observation capability, effectively removing the submarine's ability to remain unseen. In practical terms, there was nowhere left for it to hide in the operational picture. At that point, the message was clear. Modern underwater stealth could delay detection, but not prevent it when multiple layers of surveillance were working in sync, from space, air, and sea. Whether this marked the end of the escalation or simply the beginning of a more aggressive phase remained uncertain. What was clear, however, was that the balance of control had shifted, and the rules that once governed the engagement no longer applied in the same way. The Kremlin ultimately committed to a full saturation strike. The Admiral Grigorovich destroyer launched its entire load of 8 Kaliber cruise missiles in a single coordinated salvo. At the same time, the exposed Kilo-class submarine delivered a last desperate response, firing both live torpedoes and acoustic decoys in parallel. The effect on the NATO formation was immediate. Defensive systems went into maximum activity, attempting to distinguish real threats from simulated signatures. Anti-torpedo measures engaged across the fleet, flooding the water with counter-noise and interception attempts designed to break tracking solutions. Even with airborne patrols scanning for incoming vectors, confusion spread through the battle space. Multiple approach paths appeared valid, and the acoustic environment became increasingly difficult to interpret. In the chaos, one torpedo, completely silent and undetected by active countermeasures, slipped through the layered defenses and headed directly toward the formation. On board the USS Carney, every display shifted into emergency status. A full defensive response was triggered. SM-6 interceptors launched in quick succession to engage the incoming Caliber missiles at range. Several were successfully destroyed before reaching the fleet, but at least 2 managed to penetrate the outer defensive layer. In response, carrier-based aviation was activated in a coordinated sequence. The F-35C took off first, operating in stealth mode and leaving no clear signature for enemy sensors. Its role was not direct engagement, but reconnaissance and electronic mapping, identifying the location of radar nodes, fire control systems, and air defense infrastructure protecting the Russian formation. Once that targeting picture was established, F/A-18E/F Super Hornets moved in from outside the high-risk envelope. Using the intelligence provided, they launched precision strikes aimed at disabling the previously identified air defense network, systematically reducing the enemy's ability to coordinate further attacks. Meanwhile, close-in defense systems engaged at the last possible moment. One Caliber missile detonated near the ship's bow, sending shockwaves across the water, but the primary danger remained beneath the surface. The incoming torpedo was now only a few hundred meters from the hull. General quarters alarms continued as the ship executed an emergency evasive maneuver. Countermeasures deployed immediately, releasing decoys designed to draw the torpedo off course. In the final seconds, the weapon veered away, passing just off the ship's flank without impact. The formation held. On the opposing side, Russian forces found themselves increasingly exposed. With key sensors and coordination nodes under pressure from coordinated air and electronic attacks, their ability to sustain the engagement degraded rapidly. The remaining submarines withdrew deeper, while surface units began to disengage in an organized retreat. The exchange demonstrated a central reality of modern naval conflict. Success is no longer defined by raw firepower alone, but by the ability to maintain awareness, coordination, and decision-making speed when the environment becomes fully saturated with noise, deception, and overlapping threats.